Hello everyone, my name is Zhenming, and today, on behalf of Team 9 of the module BAC2002 Blockchain Technologies and Cryptocurrencies, I will be demonstrating our project's execution. Our project is not as simple as one might imagine, as there are several components that need to work together to make the entire system flow smoothly. With that being said, do bear with me, but there are these 4 components that I'll be going through today. First of all, we will demonstrate a contract deployer deploying the smart contract, followed by the contract deployer assigning the institution admins. Third, we'll have the institution admin minting the NFTs for the institution users. For example, the SIT Registrar Office will be minting identity cards for students or professors. Lastly, I will demonstrate an institution users collecting these NFTs on its mobile phone. With that being said, let's dive straight into it. Right, so now let's focus on the first part, which is deploying the smart contract. First, head to this repository, github.com, VeriZKP, and you can do your own reading on your own time, but for now, let's head to this smart contracts repository, click on it, and as you can see, we have 3 smart contracts here, but for now, we'll be using the soulbound.so, so click on it, and what you can do here is copy the entire raw file. Next, head to Remix IDE, and here you would create a new file, so let's click on this. Type soulbound.sol, but I already have this file, so I'm going to name it soulbound_1.sol and paste the code we have copied just now. Next, head to this Solidity compiler and compile the Solidity file. Once you see a green tick here, it means that it has successfully compiled, and you can head to Deploy and Run Transactions tab here. On this part, be very careful. The first thing you should do is head to the environment and change to Injected Provider MetaMask. Just to double confirm, head to your MetaMask extension and make sure that you are connected to the correct account. In my case, I use Contract Deployer as well as connected to the correct network. You can use either Scroll-Sepolia or Sepolia, but not Ethereum mainnet. Take note of that. With that being said, let's deploy the smart contract. A confirmation pop-up will show up here, and just click on Confirm. And as you can see here, a green tick indicates that the contract has been successfully deployed. So before we wrap this up, 2 important steps. First step is to copy this address and paste it somewhere. I will just put it on our sticky note here. This is for future usage, right? And also on the Solidity compiler, remember to copy this ABI, and what I like to do is I will head to Visual Studio Code. I've created a temporary folder. I'm going to create a new file called soulbound.json. .json is the extension for contract API, so use that and paste your API code here. And with that, this will wrap up the first part of our project. Now, on to the second part. So here we're going to assign the institution admins. So on this part, if we head to the Deploy and Run Transactions tab here, under the Deploy Contracts, you can see that there is this function called assign admin. That needs an address and a screen. So what I'm going to do is, I've already prepared 2 accounts for that purpose. So I have this SIT admin as well as OB admin. What I'm going to do is, I'm going to copy its wallet address, I'm going to paste here, I'm going to type SIT. Click on Transact. Once again, we wait for the confirmation pop-up to show. And we click on Confirm. Same thing, I will repeat it for the UOB address. I'm going to copy this and paste it here, and I'm going to type UOB. Click on Confirm, and here this green tick indicates the previous transaction has been successful, and this green tick indicates that UOB has been successfully assigned as well. To confirm that, we also prepared a function called getAdmins for sanity check. If we click on that, you can see that it returns one address for SIT and another address for UOB, indicating that it has been a successful transaction. So with that, this wraps up the second part of the project. Right, welcome back. Now we're going to the exciting part of the project, the third part, which is institution admin, minting NFTs for the institution users. So what you want to do is, you want to come to this GitHub repository again, scroll down to this NFT issuer. Now, if you are interested in installing or having this whole project on your computer locally, you can follow the instructions here, but if not, you can head to this live website that we've prepared to demo it yourself. So what you want to do here is, you head to the sticky note just now, copy the contract address and paste it here. And for the file, this is actually referring to the ABI file that you have saved just now, so you upload that here in my temporary open it and you submit it. And with that, you'll be greeted with this interface where you can mint the NFTs. So how you want to do this is, first of all, head to a MetaMask, ensure that you are signed in as a correct account. So SIT admin on Sequoia. That was the blockchain that I deployed my smart contract. That you can connect, and there you go. You are signed in as an SIT registrar office now. And subsequently, now what I want to do is I want to mint this NFT for an SIT student. So I have this account here. I'm going to copy this wallet address and paste here. I'm going to give it my name. And I'm going to mint the NFT. So the pop-up will show here and just click on confirm. There we go. Okay, now I would mint another NFT here just for demonstration purpose, as I'll explain it a bit later. Right, so now you can head to this minted NFTs and you click on refresh. You can see that there are actually 2 NFTs here. Now what I would do is, Professor is not really me, as I'm actually still far from that, so I'll just gonna revoke this NFT. And this will become another transaction, as I need to confirm here. And once that happens, you can see that this has a status called revoked. Even if I disconnect and reconnect again and refresh, it will still show that it has been revoked. And this is an information that is broadcasted throughout the entire smart contract. So with that being said, that wraps up our third part as well. Welcome back. So now we're looking at the fourth part, which is collecting an NFT as a student would suit. But before that, I'd like to highlight that just now, I've used the UOB account to mint 2 more NFTs for myself. I did one accidentally by repeating it, so I revoked it. So as you can see, there's one NFT that is in circulation and the other one is revoked on the UOB side. So to note, I'm expecting 2 NFTs to show up as a user right now. So for part 4, you want to head back to the VeriZKP GitHub repository again. And now we're going to focus on this ZKP generator. You can click on the repo link and follow along the instructions to set it up locally on your computer. Or, once again, you can head to this website here to use the live version that we have created for your demonstration. So again, what we're going to do here is we're going to copy this contract address and paste it here. Select the API file and click submit. You should be greeted with this scene right here. So what you can do first is make sure that you're connected to the right account now. So for myself, I'm using student intern. Make sure it's student intern and scroll support. This is correct. So now I'm just going to click on connect and refresh data. In 1, 2, 3. Our student card shows up here. So this is my student card. This is a UOB intern. Take note that the professor card and the double entry UOB card did not show up because it was already revoked, right? So with that being said, this proves to be a very efficient identity card management system. There are 4 information on the app surface. So there's the UOB, intern, institution, position, name, the ID, hash, and prevent data leaking as well. So with that being said, that concludes our 4th part of the demonstration. Hello everyone, welcome back. So now we're going to get into a bit more of the technical explanation part, so let's get into it. What I'm going to focus in 2 main things, explaining the smart contract as well as the minting process. So first of all, this is our smart contract. As you can see, it is using an ERC721, an NFT standard, as well as implementing the access control and reentrancy guard to protect our blockchain against malicious attacks, for example like the DAO attack in the past. So take note that we name it ERC5727 is because we actually take inspiration from this standard in proposal and draft yet, but the idea is very interesting, so we thought to implement it. So there's a lot of similarities between what we've implemented here and what I proposed there. With that being said, within our smart contract, there are 3 main actors as I've demonstrated just now. First of all, there's a contract deployer which can assign the admin, revoke the admin, or lastly like get a list of the admins for sanity check. So you can imagine this is for like maybe the government. You need to know a list of players or institutions that are participating in this entire system, and this can also prevent inflation or like abuse of the system because there's someone that can control who is using this useful system, right? Then for the second part, there's this institution admin function that I've demonstrated. They can issue the NFTs, they can revoke the NFTs as well, and then get institution and get authentication token. It's just some helper functions to smoothen the entire process. Thirdly, we have this institution user function, and there's technically just one main function, which is get all the received token details. Note that this is just returning the tokens that are not revoked yet. So there's this very fair design that allows it the revocation process. So yeah, that concludes our smart contract, and I'll see you all in a while. Welcome back everyone. So now I'll be going through the last part of the entire project, which is actually the minting process. So here I am on the NFT issuer page again. You can see there's actually an image on the side here. Note that this is an interface, but it's actually creating an image, and we're storing most of our information on IPFS, which we use Pinata here for the example. And this is what we stored just now. You can see that this is the image of the story card, and also this is the metadata. And if you put it in, you can see that there's information of my name, the identity number, and the identity number hash, position, institution, and the image location as well. So it's like a pointer, right? And this information is actually stored on the smart contract. So that would conclude our explanation and also our overall demonstration of the entire project. Thanks for tuning in.